Hello, this is Lauren Bobel, and I'm going to be showing you how to do what's called the equal values method. So, in class this week, we're going to learn about how do you solve what's called a system of equations or two different equations for x and y. We're going to learn how to find the solution or the point that works for both of them. But this video is all about how do we do this with algebra using what's called the equal values method. So like I said, we're trying to find a solution for two equations where the two lines cross on the graph. That is going to be the solution. But yet again, I'm showing you how to do this without a graph and how to do this with algebra. Please take notes while you watch this video. It will help you with the assignment that you need to do in async this week. Feel free to pause the video at any time that you need to. Okay, so here's an example. All right, let's say we've got these two linear equations, y equals negative 2x plus 5 and y equals x minus 1. Okay, now we know that the x and the y values at that point that works for both of them, they've got to be the same numbers. So what we do is we say, okay, well, the y's need to be the same number at that point. Maybe it's 0, maybe it's 6, who knows. But because the y values are going to be the same at that point, we can go ahead and set those equations equal to each other without y being involved. So instead of writing y equals negative 2x plus 5 and y equals x minus 1, we can just say, all right, well, I know that the first equation needs to equal the second equation at that point. So that's why instead we write negative 2x plus 5 equals x minus 1. All I did there was I got rid of the y's and I just set those two equations equal to one another. My next step, I'm just solving for x, what we did in Unit 2, how to solve for x. So I added 2x to both sides, and I added 1 to both sides, and I get 6 equals 3x. I divide both sides by 3, and I end up with x equals 2. Now, that tells me that the point that works for both of those equations, the x value there, is 2. And how do I get the y value there? Well, I know my x value has to be 2, so I just plug it in to my original equations at the top there, and that will tell me what y is. So for y equals negative 2x plus 5, I simply put in the 2 for x and solve that equation. You can see that near the bottom. Y equals negative 2x times 2 plus 5. Okay, so negative 2 times 2, negative 4. Add 5 to that, and I get 1. Same thing with that other equation, okay? Y equals x minus 1. Okay, I just simply sub in 2 for x. Y equals 2 minus 1, so y equals 1. And that is my solution. It's not a single x value and a single y value. It's the point where they intersect. So 2 comma 1 would be my answer here. Now the very last thing, what I like to do to make sure I got the exact right answer is I plug in the x and the y values in the end and I see, does it work out? So 1 should equal negative 2 times 2. I just put in my 1 for y, my 2 for x, and I see, okay, 1 equals negative 2 times 2 plus 5. 1 equals negative 4 plus 5. Yes, that worked out. And I try it with my other equation as well. It's important that you use both equations to check. So for the next one, I say, okay, well, y equals x minus 1. I'm going to sub in 1 for y. and 2 for x, and 1 equals 2 minus 1. Does that work? Oh yeah, it does. So I would write this example in your notes, but I'm going to show you 2 more examples in this video. Okay, so this is going to be what your work looks like today. Okay, find the solution to the following system of equations. Okay, I've got y equals negative 4x plus 6 and y equals negative 2x minus 6. Okay, so step 1. Let me just expand this a little bit. Step 1. Set both equations equal to each other. All right, so instead of writing y for both of these, I'm going to set them equal to each other. So negative 4x plus 6. Instead of having that equal y, I'm going to have it equal the other equation, negative 2x minus 6. Okay, now I'm going to go ahead and add 2x to both sides. All right, so now over here I've got negative 2x plus 6 equals negative 6, because that negative 2x and that positive 2x canceled each other out. Okay, but I still want to get the x by itself here. So I'm going to go ahead and say, all right, I'm going to subtract 6 from both sides. All right, so now I got rid of the plus 6 on the left-hand side. And now I've got 2x equals negative 12. All right, my x still isn't quite by itself yet. I need to get rid of that negative 2. So it's negative 2 times x. How do I undo multiplication? I simply divide on both sides. So I'm going to divide both sides by negative 2. And in the end, I get x equals 6. All right, now let's talk about how we solve for the y value. Okay, well, the y value is just going to be me plugging in what I got for x over here. So step 2 was solving for x. So step 2 was solving for x, which I just showed. Step 3, we're going to solve for y. All right, so it doesn't matter which equation I pick here. I'm going to check in the end to make sure I did it right. But here I'm going to say, okay, y equals negative 4. And instead of putting in x, I'm going to put in what I solved x to be, which is 6. And then plus 6 in the end. So I've got y equals negative 4 times 6. That's going to give me negative 24 plus 6. And then finally, negative 24 plus 6, that's going to be y equals negative 18. Okay, now, last thing I'm going to do here, step 4, is I'm going to check that this worked. Okay, so step 4, check your work. All right, so y should be negative 18 and x should be 6. Okay, so first of all, negative 18 equals, I'm going to check that first equation, negative 4 times 6 plus 6. Okay, that's negative 24 plus 6. That's negative 18. Yep, that worked. Okay, now let's check the other equation here. Okay, so yet again, y is going to be negative 18. But I'm going to check my second equation now. Okay, so negative 2 times 6 minus 6. All right, so my answer is going to be, let's see, negative 2 times 6, that's negative 12. minus 6. All right, and negative 12 minus 6 equals negative 18. Yep, that worked. So I set my equations equal to each other. I solved for x. I plugged my x into one equation to solve for y. And then my last step was to check my work. And of course, your official last step would be to write the answer. So the answer to this problem is going to be my x value, which is 6, and my y value, which is negative 18. So that would be my answer right there. Just going to put a little, pardon my handwriting, answer. That is our answer. Okay? And we always list our answer as an ordered pair, meaning you need both the x and the y value represented in a point. Okay, now this one, it's not set equal to y, it's set equal to x in this one. Does that matter? Well, I mean, it matters when we graph. It's a little bit trickier to graph when things equal x, but as far as solving algebraically, no, it doesn't actually matter here. Okay, so I'm not going to list the steps this time, but I'm still going to do this example problem. Okay, so first thing I do here is I set the equations equal to each other. Now I've got x isolated on both sides. I'm not going to have x equals x. That's not going to help us. But I can still solve for y here. So I'm going to do y minus 10 equals negative 3y plus 4. Okay, my first step here, I'm going to go ahead and add 3y to both sides. Plus 3y. All right, so now I've got 4y minus 10 equals 4. Okay, now I'm going to add 10 to both sides because I need to get that y by itself, so I need to start getting rid of the stuff that goes on that side with y. So now I've got 4y equals 14. Last step to get y by itself here, divide both sides by 4. And in the end, I get y equals 3.5 or 3.5, however you want to write it. Okay? So now that I solve for y, my next step is going to be to solve for what x needs to be here. Okay? So I'm going to use the first equation. X equals y minus 10. But instead of having y, I'm going to have x equals 3.5 minus 10. And I plug that into my calculator, and I get that x is equal to 6.5. Okay, so last step here, let's check our answers. So x equals 3.5. All right, let's see. We're going to plug in what we solved for. So 6.5 equals 3.5 minus 10. Yep, that works out. 3.5 minus 10 is 6.5. Let's check our other equations. So we want 6.5 to be equal to negative 3 times 3.5 plus 4. Okay, so, oh, sorry. This should be negative 6.5, right? My bad. All right. Pardon my algebra. Hopefully you were paying attention and saying, wait, that doesn't work out, Miss Bobel. Because it wouldn't have. All right, so this is actually negative 6.5. Okay, so negative 3 times 3.5, that's going to give us negative 11.5. Yes? No. Negative 10.5. Maybe I should be using a calculator right now. We're going to add 4 to that. Okay? Negative 10.5 plus 4 does indeed give us negative 6.5. So both of our answers worked in the end once I put in the correct value, which was negative, not positive. So we know we did this correctly. So now in the end, we know our answer is the x value. Careful here. It's negative 6.5, right? It's not just the first one you solve for, because the first thing we actually solved for here was y. So make sure that you're putting in the correct value for each. X, in this case, ended up being negative 6.5, and y was 3.5. And that's your answer. Okay, so hopefully this made sense. Yet again, I would have written down those steps if I was you on this slide here, and use this method to solve your problems in the little practice quiz that we have for you now. Great. Thanks very much, and I'll see you guys soon.